Today we're going to be covering integer operations for our seminar, and our learning objectives, or our I can statement for today, will be I can apply operations to integers. I would like you to put this in your notebook, so at this time would be a good opportunity to pause the video and go ahead and write this in the top of the page in your notebook. So integer operations, what we'll be looking at is positive and negative numbers and the different operations that we can apply to them. Now keep in mind that our different operations are addition, subtraction, multiplication, and division. Now typically from here on out we might not see the multiplication symbol or the division symbol. Rather, I think I will be using parentheses to signify multiplication, or simply a fraction to signify division, such as 10 divided by 5, something along those lines. So just get used to using those different symbols, as the extra multiplication and the division sign tend to go away as you move further and further into algebra. So what you will end up getting, if you're part of the seminar, is that you will receive this sheet. And what it does is it lays out the different operations that we'll be applying. So we have integer addition. We'll look at when the numbers are same signs as well as different signs. We'll look at integer subtraction and a simple method to remember when doing subtraction with integers. We'll look at multiplication of same signs, different signs, and we will do the same with integer division, looking at the same signs and different signs. So let's go ahead and get started with a couple examples. So we'll start with the integer addition for right now. So what it tells us here is that you're going to be, if you're doing integer addition and both of your numbers have the same sign, what you're going to do is add the numbers, and then the answer is the same sign as the numbers in your equation. Now that might be kind of hard to understand just based off words, so let's go ahead and look at a couple of examples here. And as I'm doing the examples, you might want to be writing them in this area here. So I'll swap this out. So first, let's take a look at something simple such as 10 plus 6. Now this is something that you're used to seeing, but they are integers. They're both positive numbers. So what this we get is 16. Pretty painless so far. So another way to kind of think about this when you're doing integer addition is to think, well, I have 10 positives, so and 6 positives. Now if we were to have negatives in here, negative would cancel out a positive, but in this case they're all positive, so we'd count up the total number of positives that we have, which would be 16. Now, this is a good method when working with smaller numbers, but since when it gets bigger, it's going to be more and more difficult to make a long list of positives and negatives. So in this case, what it tells us is that you're just going to add them together, and then the sign of your answer is going to be the same as the integers that you've added together. So let's take a look when our signs are also the same still, but let's take a peek at negatives. So let's look at something such as negative 3 plus negative 4. So what we'll do is just add them together, and the sign will be the same as the numbers that we have. So in this case we should get a negative answer. But let's take the same approach as what we did with this top equation here, and do the same thing but with negatives. So on this side we have 3 negatives, and over here we have 4 negatives. So in this case, we don't have any positive or negatives that are going to cancel each other out. So we're just left with negatives. So we have 1, 2, 3, 4, 5, 6, 7 negatives. So our answer is -7. So that's when we have integers with the same sign. So add the numbers and your answer is the same sign as the numbers in your equation. So in this case, both were positive, yields a positive answer. Down here, both were negative, we get a negative answer. So then let's take a peek at the different signs when you're doing integer addition. So let's look at something like, and I'll move this out of here. Remember, your example can go right here. So let's look at something such as, and just stick with B. Let's say we have 12, let's say -12 plus 5. So what we're going to do here, and one thing to keep in mind, I'll show you a couple methods here that we can use for this approach, but one thing that you can do is subtract the numbers, and the answer is going to be the same sign as the bigger number, and we use bigger in quotes because it's not technically bigger, it's actually smaller, but I'll show you what I mean by that. So first and foremost, we're going to take the absolute value, which is how far a number is from 0. So let's take the absolute value of 12 plus the absolute value of 5. Now the absolute value of 12, -12, would be how many spaces it is from 0, and in this case, it's 12. Typically with absolute value, your answer is always going to be positive. So here we have 12, and here we have 5. But instead of adding here, what I'm going to do is subtract. So 12 minus 5 is 7. But now we need to look back up at the top for this answer and say, well, let's put 7 here. Which of these numbers is bigger, or which one has more? Well, in this case, there's more negatives than there are positives. So we end up with -7. Now another quick approach, kind of the same idea that we used before, is listing the number of negatives and positives. So here we have 12 negatives. See how these can get kind of long at times. So using this approach isn't always the best, but if it helps you at first, use it. And we have 5 positives. Now, a positive cancels a negative, so that means we can just get rid of these ones that match up, which leaves us with 1, 2, 3, 4, 5, 6, 7 negative signs. So -7 would be our answer in this case. Now if we go back, we will move to integer subtraction. And there's kind of a cool method that you can use for this. And we call it the keep change change method, or the cha-cha method, as Mr. Sackett may have taught you in 6th grade. So how do we do this? First, we're going to keep the first number the same. Secondly, we'll change the subtraction symbol to an addition symbol. Third, we'll change the sign of the second number, and then ultimately follow the rules of addition. Now, keep in mind, you can just write your example right here, the one that I write on the opposite piece of paper, like I have been doing. So, let's think of this. Let's get a problem written down here. So let's say something like 14 minus -3. So thinking back to that keep, change, change method, we're going to keep the sign of this first number, which in this case happens to be a positive, but we're not going to write a positive here. We just assume, or we know, that 14 is positive if there's no sign to indicate that it's negative. Secondly, we're going to change the subtraction symbol to addition, and then change the sign of the second number. So we have 14 plus a positive 3, or we can just think of that as 14 plus 3, which is equal to 17. So that's one example of this. So secondly, go through another example here. Let's say we have something like negative 8 minus 2. Well, the same rule will apply here as well. What we can think of is we will keep this first number. So negative 8 will stay negative 8. We will change the subtraction to addition, and then change the sign of the second number here. So right now this is a positive 2, so what we would need to do is make that a negative 2. So we'd have negative 8 plus negative 2. Now this just comes back to the first thing we talked about with integer addition when they have the same sign. So we'd have negative 8 plus negative 2. So 8 negatives plus 2 more negatives would give us a negative 10. We can also follow this way to see how we get negative 10 by going 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. None of these will cancel with a positive, so we end up with 10 negatives. This is probably the most tricky of the integer operations, but if you follow the keep, change, change method, you should have no problem with this. All right. Moving on then to integer multiplication and integer division. Now these are probably two of the easiest integer operations that you can do, simply because the rules are a lot less complicated. Again, the examples you can put down here in both the integer multiplication and integer division. So first, let's look at same sign. Start with a problem that we've all seen many times, 2 times 4. Now both of these are positive answers, so the answer that you're going to get is positive, and that's 8. Same goes for if it was 2 negatives. You would have negative 3 times negative 7. Negative times a negative is a positive number. We won't get into the logistics of why that is because it is complicated, but just know that a negative times a negative is a positive, or when the signs are the same, you have a positive answer. And it will always be that. So those are a couple examples for same sign where answer is positive. Now let's take a peek where our signs are different. Now if your signs are different, you're always going to have a negative answer. So such as 5 times negative 6, which gives us negative 30. Or let's say we started with a negative number, like negative 9, times 5, which is negative 45. So if signs are same, your answer will always be positive. If signs are different, your answer will always be negative. So, and what's really cool actually about this is, with integer multiplication and division, is that it follows the same rules. So that's never going to change. If the answer is positive, the signs are the same, and if the signs are different, the answer is going to be negative. So let's get a couple examples down for you here. So if your signs are the same, let's say we had 20 divided by 4, which is 5. Could also go along the lines of having two negatives, where we would have negative 15 divided by negative 5, which is going to be a positive 3. So that's if your signs are the same, you will get a positive answer. And on the flip side of that, 24 divided by negative 4 is a negative 6. When the signs are different, your answer is always negative. And last but not least, negative 50 divided by 10 would give you a negative 5. And that's as simple as integer multiplication and division is. If your signs are the same, your answer is positive. If your signs are different, your answer is negative. So hopefully you've copied all of these examples down onto your note sheet. This note sheet will be beneficial to keep in your notebook, so maybe you fold it in half and tape it in there, and then you have it there for reference whenever you run into integer addition, subtraction, multiplication, or division. One thing I do want to note, I apologize for using X's here. I know that I said I would use parentheses instead, so in the future I will do that, but for now I did use the X for multiplication, which is okay, but in the future I do want to use the parentheses. So that was a seminar on integer operations. Remember, your learning objective or I can statement was I can apply operations to integers. So hopefully after watching this video and taking notes, you will be successful in the area of integer operations.